So this whole chapter we've talked about limits, right? Limits, we haven't used any, we've just how to find limits, right? The idea of what a limit is, how to find it, all that good stuff. How to find it using a graph, how to find it using an equation, how to find it using a table. We really haven't done a lot of table work because it's just not there, right? They don't usually ask you to find using a table. So what's the purpose of a limit? Well, a limit tells us about continuity, which is what we're going to talk about today, continuity. So before we get to all the limit and continuity stuff, I have up here, I have 3 pictures of the continuities we've seen so far. That's it. Those are the only kinds of continuity, discontinuity, I should say, where it's not continuous. Okay, the first one is a hole, right? A hole. It's called removable discontinuity. That's the name for it, or a hole, sometimes they call it. Okay, we talked about when this happens earlier in the chapter. The next one is called the next 2 are called non-removable discontinuities. Okay, non-removable. Wait, let me see, give me 1 second. So yeah, the second 2 are called non-removable. Sometimes you'll see them called essential. So sometimes they're called essential discontinuity. Sometimes that's called, they'll throw in that name. It's not, you don't see it a lot, but sometimes you do see it. So when they say essential discontinuity, that means one of these 2 guys. Okay? One of them has to do with an asymptote, right? One of them has to do with a vertical asymptote. The other one has to do with a jump. It kind of looks like a jump, right? So when do we see vertical asymptotes? We talked about that, right? When you get 0 on the bottom, right? When you get something with 0 on the bottom, when you plug in a number and we get 0 on bottom, but a non-zero on top. So non-zero over 0. Non-zero over 0, that's going to be this guy. When we get 0 over 0, that's going to be this guy, right? When do we get the last one? Only with what's called a piecewise function. Piecewise function. Piecewise. Okay? That's when we get this guy. Okay, piecewise function. Yeah, so those are the 3 types of discontinuity. So we have a way to check, right? We have a way to check. Which one is it? Because they might ask, do you have a hole? Do you have vertical asymptote? Do you have jump? Well, if it's a piecewise, then the only one we can have is jump. So for example, piecewise, let me try to give you a piecewise function. Let's see where it was. 1. No, not that one. We'll see them today, but I'm trying to find one. No, we'll find one today. I'll show you what piecewise function is. Removable is when there's a hole. Vertical asymptote is when you plug in a number, and we get something over 0, right? So the only 2 that would give us D and E, right, are non-removable. That's why they're called non-removable, because you notice at that value here, whatever value it is, they're not saying what value, but at this value, right, there is no limit, right? This guy, because there's no limit, because it's an asymptote. This guy, because they're not connected, right? There is a limit here. There is a limit for removable. That's why it's called removable. Okay? So that's just the visual. You're not going to see a lot of visuals today. You're going to see a lot of equations, and we have to tell which one it is. Or is it continuous? So how do we know if it's continuous? Here you go. It has to do with limits. So if we want to check continuity, we have to check limits. Okay? So at any point, I call it C, any point, doesn't matter what point. At any point, we can check the left-sided limit, the right-sided limit, and get the y value. If all of those numbers are the same, it's continuous at that point, whatever it is. If one of those numbers or 2 of those numbers, or they're all different, then it's not continuous. And it's one of these guys there. One of these three guys. Okay? So that's what we're going to start out with. We're going to start out with, is it continuous? And if it's not, how do you know? So when they say, sometimes they'll say prove discontinuity or show any discontinuity. We're going to check this guy. That's the guy we're going to use right here. Okay? All right. Okay, so first thing is a picture. They do give you a picture. So we have, find the points or intervals at which the function below is continuous and the points at which it is discontinuous from 0 to 5. So when x is 0 to x is 5. Okay? All right, so let's make two lists. One for continuous and one for non-continuous. Let's do continuous first. We'll do continuous. Actually, you know what? It's probably easier to point out the not continuous parts first because we already have it on this page. Okay, so if you're looking at this guy here, how many points of discontinuity does it have? In other words, how many times do you see those three pictures at the top of your page? How many times from 0 to 5 do you see those pictures at the top? I see it 3 times. Yeah, I see it 3 times, right? So where's the first discontinuity? When x equals 1, right? There's a hole. Yeah, there's a hole. What's the second time you see it? 2. There's an asymptote, right? What's the last one that you see? Jump at 4, right? There's a jump there. Everywhere else in between, it's continuous. So let's say, not continuous. So where is it not continuous? Oops. When x equals 1, we said. When x equals, comma, when x equals 2, and when x equals 4. Everywhere else, it's continuous, right? Everywhere else, it's continuous. Okay, so let me save some space here. Okay. Okay, so everywhere else, it's continuous. So where does it start? So it's an interval. Where does it start being continuous? 0, good. And when does it stop being continuous? At 1. So 0 to 1 is our first interval. Okay, so we're at 1, right? After 1, it starts being continuous again. And when does it stop being continuous? 2, all right? And then at 2, after 2, right, it's continuous. And when does it stop being continuous again? 4. Good. And then there's one more discontinuity, right? After 4, right? And then when does it end? 5. So it's got 4 areas of continuity, 3 points of discontinuity. Okay? All right. That's visual. Okay? The next one, we're going to use the definition of discontinuity to do the same thing. Okay, so here we go. Same picture. It's the same picture. We have 3 discontinuities, 3 areas of discontinuity at 1, 2, and 4. So what they want us to do is at those 3 points, they want us to find f of c, find the limit, the right-sided limit, left-sided limit, overall limit. Okay, so let's set this up. So we'll do the limits first. So there's 3 different places we have to do this, right? So let's start at 1, x equals 1. Okay, so the first thing we're going to do is find the left-sided limit, or sorry, the right-sided limit. Then the left-sided limit. then the overall limit, and then f of 1. Okay. I put equal signs, but doesn't necessarily mean it's going to be equal. We're checking. Now, is it continuous or not continuous at 1? What did we say on the last, what did we say on example number 1? Was it continuous or not? Not, right? So what should happen is at least one of these numbers should be different. Okay? Some of them will be the same, some of them will be different. So let's start with the right-sided limit. The limit as x approaches 1. What is the limit as x approaches 1 from the right side? 1, right? Comes down here, and the y value is 1. How about from the left side? Also 1, right? Well, if those two are equal, what's the overall limit? 1. So far, so good. So the last guy has to be the problem. What is the y value when x equals 1? 3. That's where it doesn't behave.
So 1 minus.
Okay? So because the last guy is not equal to the same thing as the others, we say it's discontinuous. Okay? So now let's do positive 2. So again, we're going to say the limit as x approaches 2 from the right for the function, the limit as x approaches 2 from the left for the same function, and then the overall limit at 2, and then f of 2. Same thing, right? Same thing. We're going to find the limits at each one of those areas. We already know it's discontinuous because we said that on example number 1. Now we're showing why it's discontinuous. This is the definition. Okay, so what is the the right-sided limit? Positive limit. What is the positive limit as x approaches 2? It's going to be a positive infinity, right? Positive infinity. What's the left-sided limit as x approaches 2? Same, right? They're approaching the same region. They're going straight up. What is the overall limit as x approaches 2?
Can't exist.
Doesn't exist. Even though they're approaching the same number, that's not a number. It's not a value. So we say d and e. And then what's the y value what is the y value at 2 when x is 2? No solution or undefined. Either one's okay. Either one's okay. It means you don't have an answer. So yeah, none of them are the same except for the first two. So that's why this guy was discontinuous at 2. So do the same thing for, what was the last one, 4? So do the same thing for number 4.
They match.
So the limit as x approaches 4 from the positive side is, from the right side, is going to be positive 1. The limit as x approaches 4 from the left side is going to be positive 2. The limit as x approaches 4 does not exist because those first two guys are not equal. And then the answer, or the y value at x equals 4, is positive 1.
I mean, we have matching, just not where we want
Yeah.
it to match.
Everywhere else on that graph, the numbers would all be the same. But those are the 3 points that they're not the same. Okay. Okay, so now we're not going to get a picture. We're going to do the same exact thing, but we're not going to get a nice picture. Okay? It's the same thing. They're asking you to do the same thing. Where is the function continuous or not continuous? Okay, so look at A. Look at 3A. Don't change it like I'm doing mine, but look at 3A. Which one of these 3 guys is going to happen for 3A? And which one's not going to happen?
A hole can't happen.
A hole's not going to happen, right? A hole is not going to happen because I wouldn't get 0 over 0 if I plugged in a number, right? Because there's 1 on top. Is there a vertical asymptote? Yeah, there's going to be a vertical asymptote. How do we know?
X is on the bottom.
X is on the bottom, right? X is on the bottom. We're going to find that out in a second. Is it going to be a jump? Is there going to be a jump at all? No, because it's just one function. It's just one function, yeah. So it's going to have a vertical asymptote. We know that. First thing we got to do is figure out where it's going to have a vertical asymptote. Okay? Some of you can do this in your head, and if you can do it in your head, awesome. To find a vertical asymptote, we set the bottom equal to 0. And when we do that, we get positive 1, right? So that means there's a vertical asymptote at x equals 1. We said there was not going to be a hole, right? We said there wasn't going to be a jump. So the only thing we have to worry about is a vertical asymptote. Are there any other vertical asymptotes? No, not that we know of, right? Because it's only x minus 1. There's no other numbers I can plug in for x that would give me 0 on bottom, right? So in that case, the only place it could be discontinuous is at 1. So that's the only value I'm going to check here. Okay? So when it says use the definition, of continuity to explain why, it's not saying in words. It's not saying like use the textbook definition in words. No. This is the definition over here. This is the definition over here. Okay? You're just showing the person I'm checking for discontinuity. You're showing whoever your reader is, right? On tested quizzes, it's going to be me. But on AP tests, it's going to be somebody else. Okay? Okay, so the only place to check is going to be at 1, right? So we're going to set up the limit as x approaches 1 from the right for f of x equals the limit as x approaches positive 1 from the left equals f of 1. That's the definition for this guy. Okay. We're going to figure out what each of these is equal to and see if they are equal. Okay. All right. Let's start with the first one. The limit as x approaches 1 from the right. How do we figure that out? What's the first thing we always do when we're approaching a value? Plug it in, right? So if I plug it in, what am I going to get?
1 over 0.
1 over 0, which is undefined, right? So this is what you did on the quiz and the week before, where we had one-sided limits, right? What did we do? Is a good review for the test coming up. What did we do when we had a one-sided limit and I got 0 on the bottom? What was my next step?
Get as close as you can to the...
Keep going. Yeah, get as close as I can to 1 to see what the heck's going on. All right?
As long as you use it on the right, on the proper side, you can't use 0.
There you go. Yeah, as long as it's on the correct side, absolutely. Okay? So we know at 1, there's going to be something going on, right? And then we have 2 and we have 3, right? We have 2 options. It's either going up forever or down forever, right? We know it looks like that. So let's do a little X and Y table real quick. So it's from the right side, correct? It's from the right side. So the right side are 3 and 2. So I'm going to try 3 and 2. I'll try 3 first and then 2 next. Okay. So when I plug in 3 to the original, I get 1/2. Yeah, go ahead. I get 1/2. When I plug in 2 to the original, I get 1/1, which is 1 whole, right? Okay, so let me go graph those dots. 3 1/2. 2 1. So as I'm getting closer and closer to 1, it looks like I'm going uphill. So that means I'm going to continue to rise. So that's positive infinity. Okay. I'm going to do the same thing, but to the left side now. So this time I'm going to pick -1 and 0. Plug them in. So -1, if I plug in -1, I get -1 minus 1, which is -2. So that's 1, -1/2, right? And if I plug in 0, I get 1/0 minus 1, which is -1. 1 divided by -1 makes -1. Make 2 dots. -1, -1/2. 0, -1. So it looks like as I'm getting closer and closer from this side, I'm decreasing. Negative infinity. Now the last one, f of 1. Plug in 1, what happens? I get 1/0, right? 1/0 is an undefined answer. Undefined. None of those are equal. Because they all have different answers, or because all of them are not the same number, we've shown that it is not continuous at x equals 1. That's the only place I have to check, because that's the only place there's discontinuity. There's not going to be a hole anywhere. There's not going to be a vertical asymptote anywhere except 1. And there's no jump because it's not a piecewise function. Okay? So when they say use the definition of continuity, that's what we're talking about. Set equal, set equal, set equal. If they're all the same, continuous. If one of them is different, not continuous. Okay? All right. Okay, let's try letter B, 3B. Same thing, they're asking us the same thing, just different function, g of x this time. Okay, so which of the 3 could it have? I'm not saying it is going to have it. Which of the 3 discontinuities could it have? Could it have a hole? Yeah. Yes. Not saying yes for sure, but we're saying it could, right? Yeah. Could it have an asymptote? Yes. Not saying it does have an asymptote, I'm saying it could have an asymptote, right? Is it going to be piecewise? No. Because there's only one part to it, right? So it could have a hole or a vertical asymptote. Okay? where would it have, a hole comes later, right? So where would it have a vertical asymptote? Where could it have? -2, right? Because if you plug in -2 on the bottom,
I did the math.
you're going to have 0 on the bottom. But when I also do it to the top, am I going to get 0 as well?
Yes.
Yeah, you will, right? So now that doesn't mean there's a vertical asymptote at x equals -2. That means a hole at -2, right? So a hole at -2. So it's removable discontinuity. Okay. All right. So now that we know that, we're going to use this, this, and this. For what value? -2. So we have the limit as x approaches -2 from the positive side for g of x. The limit as x approaches -2 from the left for g of x. And then f of -2.
I think we're using G, aren't we?
Oops, yeah, sorry. I don't know where f came from.
It's the upper equation.
Yeah, it's default, and my default is f. G, yeah, make sure you change it to G. Okay.
On the AP exam,
Yes.
if you don't use the right, like if you did like F, would they mark off points for that?
That's a great question. That's a good question. I don't know. I don't think so. I don't think so
If your
because
math is right enough.
your math is right. You just made a little like error like that. So off the top of my head, I don't think so, but I would have to check. Yeah, if like you did G, G, F, a better mistake would be F, F, F. Yeah, all of them. Yeah, on my tests I wouldn't mark you off. I wouldn't mark you off because I know what you're doing. But on the AP test, I'm pretty sure they wouldn't mark you off either because they're checking to see whether you know the calculus versus little mistakes like that. Yeah, that's a great question there. Yeah. Okay. So first thing we got to do is find the left-sided limit as x approaches -2. Okay. We've had experience with this. So how are we going to do the left-sided limit? What do we do first? Plug in -2, right? Well, we already did that, right? We did that in our head. What happens when you plug in -2 to the top and -2 to the bottom? You get 0 over 0, right? We already know that. That's why there's a hole there, right? So we have to figure out which value it's approaching, right? So we're going to pretend, we're going to do this problem, but we're going to pretend like the positive isn't there, right? We're going to pretend like the positive isn't there. So it would just be regular -2, right? Don't erase it like I did, but we're going to pretend like it's -2, right? So what happens after we get 0 over 0? We would factor it, right? We would factor it. So what does that look like? Well, you'd factor the top, you'd factor the bottom. Those are our two parts, right? The top is a trinomial. So the top you'd get A is 2, B is 1, C is -6. So you'd get -12 over 1 because you multiply A times B, right? Or A times C, sorry. What are the two numbers that multiply to be -12 but add up to be 1? 4 and -3, good. So we get x plus 4, x minus 3, but then we have to divide by A. So when I divide by A, I divide this by 2, I divide that by 2. So this would be x plus 2, right? The other guy wouldn't divide. So what do? We move it up to the top. So I move that 2 up here. So it would be 2x minus 3, because this guy moves up. If we can't divide, it's got to go somewhere. Moves up to the top.
You get from out of
Yep. Okay, so let's rewrite this. So I have x plus 2, 2x minus 3. The bottom, the green, I can't really, there's no GCF. It's not difference of squares, so it's just going to be x plus 2, right? So the x plus 2's would cancel out, right? And you would just get 2x minus 3. Then we would plug in negative 2 again, right? So when you plug in negative 2, what do you get? Negative 7, right? Negative 7, okay. I would do the same thing for the other limit, right? So you would get negative 7 again. How would I do g of negative 2? There's a hole there, so it's undefined or doesn't exist, yeah. Undefined, because there's a hole there.
Come on, B or surplus. Alas, it was no one to me.
As if you didn't already establish that there was
So this one was close, but there was a hole there. So there's a limit, negative 7, but it's undefined. The y value is undefined because there's a hole there. So we would say not continuous at x equals negative 2. Okay, so the definition part, this part right here where we check the left side of the limit, right side of the limit, y value, you guys have done that. You guys have been doing that for weeks now. So that part isn't necessarily new, it's setting it up, right? Okay. All right, so let's go to C. C is the same situation. So could we have a, what was the first one? Could we have a hole here? No. Because there's no fractions here, right? Yeah, so no hole. Could we have a vertical asymptote?
No.
Nope, because there's no hole there, right? There's no denominator, numerator, denominator, there's only a numerator. Could we have a jump situation? Possibly. Possibly, right? Possibly.
Completely possible.
Okay, possibly. All right, definitely maybe. Okay? All right, so where is the only place there would be a jump situation at when x is? y1. You guys are right. Y,
Why one?
why is 1 correct?
Because it's like they're split off at 1.
There you go. That's where they change, right? If the value is less than 1, I'm going to use negative 2x plus 3. If the value is greater than or equal to 1, I'm going to use x squared. So that's where the trade-off or the split is, right? So that means could be a jump. We're going to put a question mark first. We're not sure yet, but there could be a jump. We're going to check to see if there actually is a jump. How do we check that? Check continuity. This guy over here at 1. So let's set this up. Let's see, the limit as x approaches 1 from the right for h of x. The limit as x approaches 1 from the left for h of x. And then h of 1. So if I'm checking the left side, or sorry, the right side of the limit from the right side, from the greater than side, from the positive side, however you want to say it. All the same. So I could say the right side, the positive side, the greater than side, it's all the same. Okay, so if I want to try that, where would I do? What would I do? So if I want to solve this answer here, use the second one because that's where x is greater than 1, right? So I would use this one. So I plug in 1, and I still get 1. Okay? The other one, I would use the top one, right?
Plug in 0.
And what do I get when I simplify it? Positive 1. So far, so good. How would I do the last one, h of 1?
The bottom.
Plug it into the bottom one because that's where it's equal to 1, right? It's greater than or equal to. We already did that though, right? So all of them are equal. So that means it's continuous everywhere. There are no discontinuities. So we would say continuous throughout, continuous everywhere. Or if this was a multiple choice test, they would have this instead. They'd have from negative infinity to positive infinity. Okay, that means if you see negative infinity to positive infinity, that means continuous everywhere. So even though it switches, there's no jump. There's no jump.
What I read he was talking about.
Okay. So example number 4, let's see where we're at. Okay, so we have time to maybe do one.
That's what you did on the.
Example number 4 is ripe for free response questions. So I told you guys last week that properties, right, are multiple or free response questions, properties of limits. This is another property, or this is another FRQ type question. These right here, like number 4A, 4B, and 4C. Same thing, same idea, definition of continuity, but what we have to do is we have another variable, right? What other variable do we have that we didn't have before? A. We have to figure out what goes in A's spot that would make it continuous everywhere. Okay? What would we put in A's spot that would make it continuous everywhere? That's our goal. So we got to figure out what A is so that it's continuous for all real numbers or everywhere. Where's the only place? Well, first of all, let's go back to the question we keep asking. Is this one going to have asymptotes, holes? Could it have asymptote, holes, or jump? Jump. There's not going to be any holes or vertical asymptotes, right? So we know it could be a jump there. We want to figure out what value goes for in A spot that would be no jump. That's what we want to do, right? Well, we're going to do what we did on the last problem. If it's continuous everywhere, shouldn't all of these be equal? So we're going to figure that out. We're going to figure out what value goes there so we can make them equal. Okay? All right, so we got the limit as x approaches 1 from the right for g of x. Then we got the limit as x approaches 1 from the left for g of x. And then we got g of 1, right? We want all of these to be exactly the same number. We want all of these to equal the same number. That's our goal. If we do that, we'll find out what A is. Okay? So let's start with the first one. How do I figure out what the limit is as x approaches 1 from the right? Plug in 1 to the top, right? Plug in 1 to the top. So if I plug in 1 to the top, I get, what do I get? 8. Now let's do the middle guy. What's the limit as x approaches 1 from the left? How do I figure that out? Use the bottom, right? Okay, so the bottom is x plus a. So where would I plug in 1 for, x or a? X. So it's going to be 1 plus a, because I don't know what a is. And then how do I figure out g of 1? Which one am I going to plug it in for g of 1? Top. And I already did that, right? So that one is equal to 8. So the only one that doesn't equal 8 is the middle, right? That guy's 8, that guy's 8. That guy is not 8, right? It should be 8. So this part you can kind of do in your head. What value would have to be a to make it 8? Right? So you're trying to figure out 1 plus what number equals 8? 7. So if a was 7, so if it was x plus 7, there would be no jump, just like the last problem. If a was anything other than 7, there would be a jump. So what we did was we found out the number that it would have to be so that there was no jump. Okay. All right, so let's go to the bottom, or next one. Let's see. You know what, we got about 10 minutes. I don't want to do this one because we might not finish it. So we'll finish it tomorrow. And it gives us time to, gives me time to answer questions on the practice.